And hello, students, Dr. K. This is our lesson. I'm not here in person. I took the day off. I have some plans with my family. It's amazing, greatest city in the world. I want to take advantage of it. I want to have fun. I'm coming to you from my New York City home. This is great. Life is good. We're going to do 5 problems in the 2B book, Remember, where is it? 2B, the thin book, and we're going to go to page 83. Page 83. It looks just like that. Activity 4. Look, page 83. Yes, amazing. So 2B, thin book, and we're going to do 5 questions because we are awesome. We're going to do 5 questions. So let me switch my camera. I have all my friends here. See that? I wake up, I do these because my job is to make you a math genius, and life is good and we got to take advantage of it. We are healthy, we are alive, we are well, we are in the greatest city in the world. I have the Hudson River, the hospital, everything around us is beautiful here. I'm in the Heights, right? You guys know in the Heights. Life is good. So let me switch the camera, and my job is to make you a math, what? My job is to make you a math genius. 100%. Don't ever forget that. Okay, so remember, thin book, 2B, right? The thin book, 2B, and we are on page, thin book, 2B, and we are on page 83. Okay, let's take a look. I want this to not be collected. I want the books to stay with you. Don't tear the pages out. Whoever is covering for you, as the teacher covering knows, keep the books with you. I will grade the books when I come back on Thursday. Okay, first question. I'm going to go over the questions. My job is not that you copy. I don't want you just copying. I want you truly understanding this. I want you truly solving it, truly understanding it. Okay, let's look. Question number 1. Remember, we're going to solve the first 5 questions. What is the probability that when you spin the spinner, it will land on an odd number? Let's look. This is where I want us to discuss. First of all, what is the shape of the spinner? It is a circle with pizza slices. So it's like a pizza with slices, okay? So let's just not rush into the solution. How many slices are there? Tell me. Count them. How many slices do you have? Did you get 8? 8 is correct. There are 8 slices. Okay, so let's see. So for example, slide number 1, how many slices are there for number 1? There are 2 slices. 2 slices, or 2 out of 8. 2 out of 8. So far, so good. We're just planning this out. I'm purposefully going slow. Number 2. So this is the number and how many slices. Number 2. How many slices are there for 2? What did you get? 3 slices, so 3 out of 8. Number 2, 3 slices out of 8. And what did you get for number 3? For number 3, how many slices are there? 3 slices out of 8. So 3 out of 8. Up to this point, before we answer the question, up to this point, does that make sense? This is a good time to pause the video and just make sure that everybody's caught up. What did I do so far? I looked at the pizza slices, I looked at the spinner, and I just said, oh, it's not what I expected. It's not a spinner that is 1 to 8. You know, usually we look at spinners. Usually we look at spinners and we say, oh, it's easy, Dr. K. I just see the spinners. It's 1, 2, 3, 4, 5, 6, 7, 8, or 1 to 6, or 1 to 12. Those are easier spinners. This is a spinner that you have to pay extra attention to, because the values could be repeated. So it's simple events with unlikely outcomes, right? I mean, there are different numbers of 1, different numbers of 2, different numbers of 3. So this is a different kind of spinner. That's why you have to pay attention. You have to annotate. You have to go through the steps, right? So how many ones did we say? There are 2 ones. There are 2 out of 8. 2 out of 8 slices are 1. 3 out of 8 slices are 2. And 3 out of 8 slices are 3. And when you add 2 plus 3 plus 3, you end up with 8 total. Okay, so the question is, what is the probability that it will be on an odd number? What's the probability that it's odd? Well, let's think about it. Where are the odd numbers? Is 1 an odd number? Yes. Is 2 an odd number? No. 3 an odd number? Yes. So where are they? How many slices in total would result in an odd number? Good time to pause the video, discuss, and make sure you have the right answer. Don't just wait to copy. Did you get 2 plus 3? Did you get 5 out of 8? If that's what you got, you are correct. Any questions on question 1? If you have questions on question 1, write them here on the side. Say, okay, ask Dr. K. So you remember to ask Dr. K when I come back with you Thursday. Of course, ask the teacher that's with you. They're wonderful. They can also help you. But make sure you totally understand this. Does that make sense? Okay, let's move on to the next question. You roll a fair die. You roll a fair die. Remember we talked about what a fair die is? You roll a fair die. If it doesn't tell you, we assume that the die is a 1 to 6, a traditional die 1 to 6. You roll a fair die. Find the probability of the number landing on a prime number. So let's think. A dice looks like a cube. One die looks like a cube. 1, 2, 3, 4, 5, 6. The numbers are opposite. All the numbers on opposite sides add up to 7. But really the numbers are 1, 2, 3, 4, 5, 6. It's a simple event of rolling a die, and these are equally likely outcomes. It's not the same case as we had with our old spinner from question 1. Those were unequally like outcomes. Here, right, students, math geniuses, these outcomes, 1, 2, 3, 4, 5, 6, they are equally likely. But the question says, find the probability. Remember, we always annotate. Even when I don't annotate, you still have to annotate. I can already hear some students saying, Dr. K, you did not annotate. Well, you still have to annotate. So find the probability of the number die landing on a prime number. Okay, where are the prime numbers here? 1 is not a prime. 1 is not a prime. We had this argument many times before. 1 is not a prime. What did I say? Not a prime. 1 is not a prime. We had this argument before. 1 is not a prime. 2, prime. 3, what? You want to go through this? Pause the video. Make sure you get the same list as I got. Okay, 2 is a prime. 3 is a prime. 5 is a prime. 4 is not a prime. Oh my goodness, what did I write? I'm not paying attention. I need coffee. I haven't had coffee. It's early in the morning. I haven't had coffee. 2, let me just write this way. Not prime. I should edit this out of the video. Maybe I don't have time to edit this out of the video. I'll just keep it in the video. 4, not a prime. 6, not prime. I'm going to blame Yeti. Yeti was supposed to do these for me. Yeti is my dog. He's a math genius. He didn't do it for me this morning. He's asleep. So let's see. Where are the numbers that are prime? 2 is a prime, 3 is a prime, and 5 is a prime. Does that make sense so far? So how many of the outcomes are primes? 1, 2, there. 3 of them are prime, 3 of them are not prime. So then what's the probability of getting a prime? The probability of prime. If you said, good time to pause the video. If you said 3 out of 6, you are correct. But remember, what does Dr. K always say? When you have the answer as a fraction, you always want to reduce it to its simplest form. What can we do to reduce 3 over 6 to its simplest form? 1 over 2. So let me just pause right now and regroup. Is this making sense? Is this making sense? Because there's no excuse. You have to be a math genius. Where is it? What's my job? Make you a math genius. My job is to make you a math genius. So this has got to be, you have to take this very seriously. And remember, I'm going to check your books when I come back on Thursday. Don't tear the pages out. Help each other. You could work together. You can pause this video as much as you want. And the next time I'll also give you a tour. I'll show you the river. I'll show you the views, maybe another day. But for now, let's go back to question 3. Question 3, my favorite. Question 3. Okay, question 3. Let's go down, let's scroll down to question 3. There you go. Okay, let's read it together. A letter is randomly chosen from the word, oh, my favorite word in the English language, mathematics. What is the probability of choosing a vowel? What is the probability of choosing a vowel? Mathematics. No, again, I want you to box the question or the command. I always want you to box the question or the command because I want to make sure that you've read it and you know what you are being asked to do. We are professionals. We see a question, we solve it, we get paid with grades. So we are professionals. A letter is randomly chosen, randomly chosen. So let's see. Let's kind of write the word, break out the letter. So there's an M, A, T, H. Okay, one letter. So let's keep going. Math. There's an E, mathy, math. Ticks. Like here, let's separate the S so that they are all equally spaced. Does that make sense? Let's make sure I got it right. I haven't had coffee yet, so maybe I did it wrong. And Yeti's not here to help. Math, ticks. Okay. Well, how many letters are there to choose from? Let's see. Just count the letters for now. 1, 2, 3. There are 11 letters total, right? So I could pick this M or I can pick this M. They are different M's. So it's not, we're picking a letter randomly. I don't combine the 2 M's. I don't combine the 2 A's. No, it's like I can pick this M or that M. So if I had to put these numbers in a hat, there would be 2 M's to pick from. Okay, a letter is chosen randomly from the word mathematics. What is the probability of choosing a vowel? Let's find. Out of 11 choices, right? We told me there were 11 choices, right? Yeti's not here to verify, so you have to verify. My dog is still asleep. He's my math genius partner. Let's see, where are the vowels? A, where else? E. Good time to pause the video, like I said. Always pause the video at the key moments to make sure we got the same answer. Am I done? Am I done with the vowels? No, Dr. K, you are not done with the vowels. There are more vowels, Dr. K. There's an A. Dr. K, there's an I. What else? Let's see. Are there any more vowels in here? How many? Probability of a vowel. So remember that P means probability. Probability of a vowel is out of 11. Remember, the probability is just the number of, I'm going to write the formula just so one more time. Number of favorable. When we have simple events with equally likely outcomes, it's just the number of favorable outcomes divided by the number of total outcomes. Right, write down this formula because I think it helps. So the probability of any event is the number of favorable outcomes divided by the number of total outcomes, because these are equally likely outcomes. And this is 4 out of 11. Does that make sense? Now, trick question for you. Can we reduce 4 out of 11? We cannot. That's correct. We cannot, because 4 out of 11, that's just a prime. I mean, 4 is a prime. 4 is a composite, but 2 is a prime. So we can't, there's nothing more to reduce it to, 4 out of 11. If you wanted to leave it at that, that is correct. Okay, 4 out of 11, which is, it's under 50%. Okay, let's check base. Let's check back and see how we're doing. Okay, how are we doing? How are you feeling today? Are you happy I'm not here? Are you happy I'm not there in person? Or you're like, oh no, he's not here. There's no Math Genius Fuel. There are no corny jokes. There are no Rubik's Cubes. I don't know, look, the sun is coming out. It's getting nicer and nicer. I wanted to make sure that even though we have the books, I wanted to make sure I record this video. And I hope it gets played. I hope you're seeing this. Dr. K here. Let's go to question number 4. Remember, I want you to do the first 5 questions. And of course, if some of you want to do more than 5 questions, yeah, I'll be happy. So question number 4. Question number 4. Oh, my favorite, Venn diagrams. Question number 4. Okay. A number is randomly selected from 10 to 20. From 10 to 20. So the question needs to be a bit more specific to tell you, is 10 included, is 20 included? But based on the way it's written, I would say both 10 and 20 are included. So a number is randomly selected from 10 to 20. X is the event of selecting a number divisible by 3. Y is the event of selecting a prime number. Questions like this, let's just take a moment and on the side, list all the outcomes. Again, this is one of the cases where they are equally likely outcome because a number is selected randomly, equally likely outcome. So let's just list it. List what the numbers are. There's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And remember, Dr. K does this on the board with color. Dr. K does this on the board with color. So maybe we could do that with color as well. So let's go. So X is the event of selecting a number divisible by 3. So X is the event of selecting a number divisible by 3. Let's use red for that. A number divisible by 3. Right now, this is a good time to pause the video. I want you to maybe select the numbers that satisfy, that are favorable to event X, the numbers that are divisible by 3. Come back when you have done that. You could pause the video now. Let me see, divisible by 3. So we have 12 is divisible by 3, 15. We're just counting by 3s. This is so easy, Dr. K. Oh, I know. So 12, 15, and 18, divisible by 3. Those satisfy event X. So let me write X, X, X. Okay, what are the events for What are the events for, what's event Y? Y is the event of selecting a prime number. So let's see. Another time to pause the video and go through what are the prime numbers. So of course, we know that even numbers cannot be prime. Even numbers cannot be prime. So what are the prime numbers? There's the 11, 13, 15 is not a prime. 15 is composite because 3 times 5. 17 is a prime. And also, are we done? No, 19 is a prime. So this satisfies event Y, event Y, event Y, event Y. So far, so good. Now, are there numbers that we did not select for either one? Looks like 10, we didn't select for either one. Looks like 14 was not selected, 16 was not selected, and 20 was not selected. Are there any numbers that were selected by both X and Y? No. So let's draw the Venn diagram. How do we draw the Venn diagram to represent that? We draw the Venn diagram by first drawing a big rectangle. Everything goes inside the big rectangle. Everything. That big rectangle, that is the sample space. There is nothing outside of the sample space. I mean, there might be something outside the sample space, but in this experiment, for the scope of this experiment, nothing is outside the sample space. This is the sample space for this experiment. There are 2 events, and there's no overlap. There's no overlap. There's nothing shared. There's nothing common. And so their 2 circles are not going to be overlapping. 2 circles are not going to be overlapping. One circle is going to be X. This is the X, event X, and this is event Y. What goes in event X is, well, this is a good time to pause the video and see if you could do this on your own. What are the outcomes that satisfy, that are favorable to event X? We have 12, 15, and 18. What are the events? What are the outcomes that satisfy, that are favorable to event Y? We have 11, 13, 17, and 19. And then what are the events? What are the outcomes? What are the outcomes that don't belong in either one? Now, do I write them on the outside? No, we don't write them on the outside. Nothing goes outside the sample space. Nothing goes outside the sample space. So all the ones here, they don't belong, they're not selected. But like, for example, 10, I just put them outside. 14, 16, and 20. Does that make sense? Does that make sense? Nothing is outside the sample space. Some events, some outcomes satisfy event X. That's this circle right here. All right, let me make it bigger. Let me highlight it so you see it clear. And then some outcomes are favorable. They satisfy event Y. And then there's the sample space. We always draw the sample space as a big rectangle. It's a big universe for this experiment. Nothing goes outside the sample space, except the word sample space, just to represent this is a sample space. Any questions there? Does that make sense, love? So again, you just have to know what's an even number, what's an odd number, what's a composite number, what's a prime number, what number is divisible by 2, by 3, by 4, by 5. These are the usual tricks. Remember, my goal is to make you a math genius, and the goal is to go from a test taker to a test maker. Remember, my goal is to make you go from a test. Oh, look at the beautiful view. I've got, like, my apartment has windows all across. I got the river, I got the hospital, I got the park, riverbank. It's beautiful. I see the Hudson River, I see the GW Bridge. You know, when Captain Sully landed the airplane, they went through the tower. the Miracle on the Hudson, the airplane that landed. It just went through down here, down my, and people, my neighbors could see it. I couldn't see it. I wasn't in town that weekend, but that happened, and that was an amazing moment. Okay, back to work, back to work. Let's continue. Question B, are events X and Y mutually exclusive? So keywords, mutually exclusive. If they don't overlap, look at them. Exclusive means they're not together. Are they mutually exclusive? Yes, they are. Yes, they are. They are mutually exclusive. Why? They don't overlap. They don't overlap. They don't overlap. Nothing in common. Nothing in common. Nothing is in common. Does that make sense, love? Okay, find the probability of X and the probability of Y. So last thing I'm going to do here, the probability of X, the probability of X. Well, these are what we call equally likely outcomes. This is an experiment with equally likely outcomes. So, you know, you pick from 10 to 20, and they're just equally likely outcomes. So, well, how many choices are there total? Let's count them. Remember, from 10 to 20. If you say 10, you've missed by 1. 10 is counted from 11 to 20. So let's count them. 10, 11, 12. There are 11 possible outcomes, equally likely outcome. Probability that an outcome that satisfies or favorable to X is, there are 3 choices. It's either 12, 15, or 18. So there are 3 out of 11. So probability of X is 3 out of 11. Probability of Y is, good time to pause the video. Maybe you can tell me. 4 out of 11 is correct. And if you got that, congratulate yourself. Again, those are the first 4 questions. I'm going to leave question 5 for you. Question 5 is the 12-sided die. That I'm going to leave for you to do on your own. Well, not really on your own. You're working in groups to do it, but I'm not going to solve it in this video. I want to make sure that I want to leave 1 question for you to do on your own without me going over it. And that's the video that I have for it. I don't want it to be too long. The weather is nice. It's going to be a great day. I have a long schedule of things I'm doing with my daughter and the dog. So that's why I took the day off, just personal day off. Even though I love you guys, I still love my family. I still have to take care of my family. And I'm going to see you Thursday. Be on your best behavior and make me proud. I am so proud of you. I want to see great, great work. Okay?